morning, HOD Professor A.K. Chaturvedi sir, my seminar guide, Dr. V.D. Gidwani, seminar coordinator D.P. Sharma sir, faculty member, examiner, and my batchmates. I am Anish Yadav, pursuing my B.Tech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. Today, I am pleased to be here in front of you all to deliver the presentation of my seminar topic, Tidal Steam Turbine. This is the overview what I will be presenting you in this topic. Let's start with the introduction about tidal steam turbine. What is tidal steam turbine? A tidal steam turbine is like a device that extracts power from the tides. Renewable energy technologies are becoming increasingly favorable alternative for conventional energy sources to assure or decrease your dependence on fossil fuels related issues. Tidal energy offers a vast and reliable energy source. This technology is similar to wind energy technology, with the rotation blades not driven by wind power but by tidal currents. The gravitational pull of the moon produces a swift tidal current which spins the long blades of the turbine, which in turn produces electricity via different parts of the underwater windmill. Now, why it is called underwater windmill and what are the origins of its name? Basically, it is like putting a windmill in the water, said John Bekin, a project manager for Hammerfest Strom. Or as it looks like a windmill as installed on the ocean floor and large river bed, this means these are under the water. Now let us look at the type of tidal steam turbine. Horizontal axis tidal steam turbine and vertical axis tidal steam turbine. Let's discuss this type of briefly in the upcoming slides. In horizontal axis type underwater windmill, the arrangement of the rotor shaft can be done parallel towards the water flow direction. It is designed for the current speed of 2 meters per second. 5 hydrofoils were designed on the blades from hub to the tip. The characteristic of the hydrofoils were studied both experimentally and numerically. The 3-bladed 10 meter diameter rotor has the maximum efficiency of 47.5%. Examples were like hydroxyl axis is used in the MCT or Marine Current Turbine project, the Lunar Energy project in the UK, the Tidal Steam Energy project in the UK. Let us look at the figure how the horizontal axis tidal turbine looks like. The horizontal axis tidal turbine are perhaps the most mature and promising of technologies and several companies. Example, Marine Current Turbine, Vedant Power, Open Hydro have developed hydro axis tidal turbine. Prototypes are currently undergoing testing. The rotor blade is the key component that extracts energy from the tides and primarily dictates the performance, loads and dynamic of the whole turbine system. Therefore, an efficient blade design is critical to the success of the horizontal axis tidal turbine. Let us move on to the vertical axis tidal steam turbine. In a vertical axis type underwater windmill, the arrangement of the rotor shaft can be done perpendicular towards the flow of the direction. The vertical axis turbine possesses some advantages that are simple design and installation, cheaper in production, easy in operation because generator, gear and other electrical components can be placed on top, suitable for floating system. Those are excessive in it in accordance with the condition of marine environment and production technology capabilities that exist in the developing country. There are some projects undergone through worldwide like the Enermax project in Italy, the Blue Energy project in Canada and the Gorlok helical turbine in the USA. Let us see how the vertical axis tidal turbine looks like. The vertical axis tidal current turbine possesses some advantages that promising to be developed are simple design, inexpensive manufacturing, simple installation. However, we must look care of certain facts such as low starting torques, irregular current velocity, low efficiency, cavitation and ocean environment is particularly harsh. There are number of components when we talk about tidal turbine such as turbine, gearbox, generator, cable and support. Let us see how tidal turbine is being operated. In simple underwater windmill consists of a number of blades mounted on a hub, a gearbox and a generator. The hydrodynamic effect of the flowing water past the blade causes the rotor to rotate, thus turning the generator to which the rotor is collected via gearbox. The Gearbox is used to convert the rotational speed of the rotor shaft to the desired output speed of the generator shaft. The electricity generated is transmitted to the land through cables. Let us look how wonderfully this idea has been implemented. The company Atlantic Resources is to install a 50 megawatt tidal farm in the Gulf of Kutch of India west coast. With construction starting in early 2020, the facility could be expanded to deliver more than 200 megawatts. Projections indicate that the cost of the initial 50 megawatt farm to consist of 501 megawatt turbines, which come in the cost of $150 million. The current timescale of the project final engineering plans completed in the end of 2030. Let us discuss about the several advantages and disadvantages of the tidal turbine. First, advantages. Tidal energy is completely renewable. Tidal energy produces no emission, hidden beneath the water, have less impact on the environment, low running cost, lifelong time with little maintenance, reduces the dependence upon fossil fuels. Moving on to several disadvantages. The initial cost is very high, very difficult to install. The blade must be coated to avoid corrosion, damages habitat up to 500 km away. Let us see a case study. In April 2008, the Bristol company Marine Current Turbine installed CGIN, the world's first commercial scale tidal energy generator in Stankford Lough, Northern Ireland. The working is described at the Stankford Lough. The tides drive to 16-meter diameter rotor up to a maximum speed of 14 revolutions per second, producing 1.2 megawatt of electricity. This is 400% more than any previous tidal generator and sufficient to power 1,000 homes. Let us see how it can be used as global resources. It is obviously agreed that tidal extreme energy could easily reach up to 120 gigawatts. UK has the largest tidal reserve. With this, we come to the conclusion that we believe that the intense and predictable marine current resource offers the possibility of clean energy at the cost that will ultimately be competitive not only with the other renewables, but in the long run, we believe that we complete head with the most forms of fossil fuel power generation at present day cost. These are some references from which the study is based on. With this, we come to the end. We thank you for listening.